Okay, so the last thing that we were talking about were the negative angle identities. We were looking at these six examples, and they were going to kind of help us find the negative angle identities. So when we left yesterday, we were kind of having some difficulty with these. So what I wanted you to do is I want you to find the sign of a negative pi over 4 angle. Then I want you to find the sign of a positive pi over 4 angle, but then make it negative. That's what this negative out front means. So in order to do that, we're going to find where is a negative pi over 4 angle.
In the fourth quadrant.
It's in the fourth quadrant. And what is that negative pi over 4? What in degrees?
Negative 45.
It'd be a negative 45.
Or are we referring to it as like
So that-
315?
Huh?
Are you referring to it as 315 or the 45?
No, we want to use it as that negative pi over 4, so just the negative 45. So this would be a 45-degree angle. So we have our 45, 45, 90 triangle, so can we label this triangle then? What's this top side?
1.
How about our...
Negative 1.
That's a negative 1 because we're in the fourth quadrant. And then our hypotenuse is root 2. So now, can you find the sign of that angle?
Negative.
So once you rationalize it, it's negative root 2 over 2. It started out as negative 1 over root 2. So now we need to find the sign of a positive pi over 4 angle. So that positive pi over 4 angle is in the first quadrant.
I'm already blessed.
That's our 45-degree angle in the first quadrant, remember.
No, you're not.
Over recording.
So now we're looking at the 45, 45, 90 in the first quadrant. Can we label that triangle? We already have one side labeled. What's this side?
1.
And our hypotenuse?
Root 2.
Root 2 again. So now what's the sign of that angle?
Root 2 over 2.
This one is positive root 2 over 2 for this part. But then we need to make it negative. We need to bring that negative down. We want to make that whole thing negative. So now, I was asking you if these were true or not. So is sine of a negative pi over 4 angle equal to negative sine of a positive pi over 4 angle?
Yes.
Did we get the same thing? Yes. So this is true.
Yes.
Is that true of all equations written out the same? In the sense that, like, you have the sine and then the negative whatever it is in radians. Will that always be equal to a negative sine and then whatever radian?
So that's what we're figuring out. So in this case, yes. So we get, this was just some random angle that I picked.
Right.
So you could pick whatever other angle you want
But is that like a universal truth
Yes.
between, okay.
for sine. So that's kind of what we're getting at with these negative angle identities.
Alright.
So that first negative angle identity says sine of negative x equals, it's blank. So what did we just show? That it equals
The negative sine.
the negative sine of the positive angle. So that's your first negative angle identity. So that's what you were asking.
Yeah.
Okay, so since I have the 45-degree angles up here already, we're going to do this tangent one. So what is the tangent of that negative pi over 4 angle? It's negative 1. It's opposite over adjacent, so it's negative 1 over 1, which is just negative 1. How about the tangent of our positive pi over 4 angle?
1.
It's 1. It starts out as 1 over 1, or just 1. So are those equal?
No.
No. So this one is false. Now, we're gonna do this tangent one. This tangent one is exactly the same as the one before, except we have a different angle, but now we're making this negative. So rather than drawing out my coordinate, can I just draw the triangle?
Yes.
Can we follow along with that?
Thank God.
So what's a pi over 6 angle?
Negative, or I'm sorry, 30 degrees.
It's a 30. And then we would have our 60, right? So how do we label our sides of this triangle? What's across from the 30?
1,
That's a 1. What's across from the 60?
root 3.
A root 3. And then what's our hypotenuse?
2.
2. So we're going to tie this back into where we're just going to use the triangle. We're going to tie this back into where each of these things is positive. So if we're looking at a negative pi over 6 angle, what quadrant are we in? We're in the 4th quadrant. So is tangent positive or negative in the 4th quadrant?
Positive?
It's negative.
Negative.
So what is the tangent of that 30-degree angle, that pi over 6 angle?
1 or negative root.
So it starts out as
1 over square root.
Opposite over adjacent. So it starts out as 1 over root 3, which turns into, when you rationalize it, root 3 over 3. And then what did we just say? We're in the 4th quadrant, so this is negative. So these should both be negative. How about our tangent of the positive pi over 6? So we're going to get root 3 over 3 again. And in the 1st quadrant, is tangent positive or negative? It's positive. But again, we need to bring that negative sign down. So we end up with negative root 3 over 3. So is this one true?
Yes.
Yes.
So this one is true.
So that one also follows the same thing as this one.
So that's going to follow the same logic. So this one was false where we weren't making it negative, but now where we are making it negative, that makes it true.
So does it kind of just follow whatever you do to one side, you have to do the other? If there's one negative, then there has to be a negative on the other side. for it to
Well, we're
be
going to
true.
find out. So that's the logic that we're using for our sine and our tangent. But we still have cosine to deal with. So let's do this cosine first. So we can use this same triangle because it's still the 30, 60, 90 triangle. So what's the cosine of a pi over 6 angle? It's 1/2.
Wait, pi over 6, sorry, I was doing
It's
pi
pi-
over 3.
Oh, did you do the wrong one? It's taking your word for it, Karen.
I was doing
Okay. So we're looking at our 30-degree angle. We have adjacent over hypotenuse. So we're going to have root 3 over 2. Now, is cosine positive or negative in the 4th quadrant?
It's positive.
Positive.
It's positive, so we're just going to have root 3 over 2. How about cosine of pi over 6 in the 1st quadrant? We're still going to get that root 3 over 2, because we're still taking the cosine of the same thing. Are we positive or negative in the 1st quadrant?
Positive.
So is this true?
Yes.
Yeah.
So this one is true. So now before we write our rule for cosine, let's check our other cosine example. So this one we want the cosine of negative pi over 3. So that's looking at our 60-degree angle. So what'd you say that is, Kara? So this one is 1/2. And again, we're positive in the 4th quadrant. So again here, if we take cosine of pi over 3, we're going to get 1/2 again. But this time we have to bring down that negative. So are they equal?
Nope.
Nope, so this one is false. So this shows us that our rule for cosine is going to be a little bit different. Here we have cosine of a negative angle is equal to cosine of the angle positive. So to answer your question, Nick, cosine
With the
is
exception.
different. Yep.
Is that because like, which ones are evens and odds? Again,
So it does go back to that.
so it goes back to which ones are even, which ones odd, further. Okay.
So then we'll just do our last example just to tell whether it's true or false. So what's sine of a pi over 6 angle?
Degrees.
So this is 1/2. Is sine positive or negative in the fourth quadrant?
Negative.
So this becomes negative. This one, we get 1/2 again. We're in the first quadrant, positive or negative?
Positive.
Positive. So is this one true?
No.
So this one is false. So that's just showing how we can generalize these. So those are your negative angle identities, those three over on the side. So those are all the identities that we are going to look at, that we're going to use to prove these other identities that we're going to look at in our examples now. So we're going to start by looking at example 1. And these examples are going to start out kind of easy, and then they're going to get more challenging. So example 1 says cotangent x sine x equals cosine x. So when we're proving an identity, what are we trying to do?
Make sure that one side equals the other.
So we want to make sure that one side equals the other side. So in this case, we want to make sure that cotangent x times sine x equals cosine x. So how could we go about trying to show one side equaling the other?
You have to get the same down. Like, you want to make the cotangent and the sine x be a cosine.
So we want to make this side become this side, or whichever side you decide to work with. All right? So in this case, do you want to make the cotangent x times sine x equal the cosine x? Is that the side that you want to work with?
Sure.
Okay. So what could we do?
Cotangent.
What different techniques do we have that we can use?
Could divide by sign.
So now, if we divide by sine,
Oh, that would cause.
we're going to change the other side. We want to prove this. We're saying that it's equal now, but it might not be equal. So we can't touch both sides. We have to use one side or the other. This isn't like solving a regular equation that we could, do something to both sides, and it would be fine. We want to make sure that these are equal, so we have to do something to just one side of the equation.
It's like what, like factor something out of the cotangent and the sine?
Well, so we have cotangent x and sine x. What do we know about cotangent x?
It
Jason,
equals
no?
cosine x over sine.
That it's cosine x over sine x? So we can rewrite it, right? We can just rewrite cotangent. So it's cosine x over sine x. And then we still are multiplying by that sine x. So now what can we do?
Cancel the signs out.
So now we can cancel the signs out. So now we're just left with cosine x.
Oh my god, it's so simple.
I'm confused.
What are you confused about, Nick?
Okay, so you had that cotangent, you had the sine, you had the cosine,
Mm-hmm.
and then you just wrote sine, or cosine and sine. What happened to the cotangent?
For here?
Yeah.
Okay, so cotangent, we know, it's one of our identities that cotangent equals cosine over sine. It was one of our quotient identities.
Okay.
So this is another way of writing cotangent.
Okay, so you just rewrote it as that, and then you canceled out your
Yes,
sides. Okay.
because we want to get this side
Okay.
to equal
I gotcha.
cosine.
I got you. We're good.
So our next example, example 2. We have cotangent x divided by cosecant x equals cosine x. So looking at this one, which side do we want to work with? Which side do we want to make look like the other side?
Left side.
So we want to make the left side look like the right side, all right? So what would we do first, Jasmine?
You make cotangent cosine x over sine x, and then you can make cosecant into 1 over sine x, and then you can flip, and then it cancels
Hang
out.
on, let me.
Okay.
So we're going to rewrite each of these. So we're going to rewrite cotangent again as cosine x over sine x. And then that's going to be divided by cosecant when we rewrite it is 1 over sine x. So we just rewrote both of those using the identities that we know.
Flip, multiply, and then cross.
So now we're going to flip and multiply. So we have that cosine x over sine x.
Multiply by sine x over.
And we're multiplying, when we flip it, we have sine x over 1.
And then you have your cosine.
And we can cancel out these signs. And we're left with cosine x. Which was what we were trying to prove. So with these, you always want to keep in mind where you're trying to get to. What you're trying to get your side to look like. So example 3. We have cosecant x minus 1 times cosecant x plus 1. And that equals cotangent squared x. So which side do we want to make look like the other? Which side do we want to work with? We want to work with the left side again? Okay. So what can we do to that left side?
You can FOIL it.
We can FOIL it. So when we FOIL this, what do we get?
Cosecant squared x minus 1 equals cotangent squared.
Well, we don't have to, yeah.
Yeah.
Are they always going to
But
be the
isn't
difference
that
of two
an
perfect
identity?
squares?
So it's good.
I'm sorry, what?
Are they always going to be, like that minus 1 plus 1, the difference of two perfect squares?
No, they might not be. This one just happens to be.
Can they always be like this, please?
Okay.
Or easier?
Alright, so we squared it, or so we FOILed it. So now, what did you say, Jasmine?
Isn't that like an identity?
Which identity is that?
The one that says cotangent squared x equals that.
So we have an identity that tells us that this actually equals cotangent squared x.
Are you good to go then?
So we're done. As long as you know that that's the identity, that's why you need to know those identities. This tells you that this equals this. It was an identity that we proved yesterday. So the better you know those identities, the better off you're going to be.
You memorize those first
Oh
tests?
god, maybe.
Um,
You have to memorize 6 of very repetitive letters.
if you know those first 3, you should be able to get all those other ones. All those other ones just were rearrangements of those first 3. So I recommend knowing at least those first 3. Know those Pythagorean identities.
What?
Alright, so we're going to look at number 4 now. Number 4 says secant to the 4th x minus tangent to the 4th x equals 1 plus 2 tangent squared x. So the first thing you have to decide is which side you want to make look like the other side.
Make the left look like the right.
So you want to make the left look like the right, okay? So what can we do to the left-hand side?
You like take out a tangent squared x out of the whole thing, and then
So you want to take what out?
a tangent squared x.
So you want to take a tangent squared x out.
Or maybe, I don't know.
Okay, so look at the left-hand side. What does the left-hand side look like?
Something like mess.
You have something to the 4th minus something else to the 4th.
Like you could make it like a quadratic, and then like 2.
What kind of quadratic is that like? If I wrote this out as x squared as x to the 4th minus y to the 4th. Can you do something with that?
Or, yeah, quadratic, look at the square root.
That's great. The fourth root and then
So what can you do, Kara?
fourth root.
So 4th root.
Oh, could you do,
I like a square
So you
root, because then you can do it to the other
Wait.
side.
You're not supposed to touch the other side.
can you do secant, squared x minus tangent squared x times secant squared x plus tangent squared x?
So this is a difference of perfect squares just like this one,
Yeah.
except this time it's to the 4th. So we're doing the same thing. So this time we're going to factor it.
But now you don't even have the 1.
Okay. So that's what our left-hand side becomes. So now, look at each one and what can we do with each one? Do we know anything about these?
Oh, wait.
Look at your identities that you know.
Oh.
Secant
Yeah.
squared
It's a good one.
and squared.
I like that.
So what do we know?
Secant squared equals tan squared plus 1.
So we know that secant squared plus tan squared, what'd you say?
Equals tan squared plus 1.
Okay.
So it's 1 equals secant squared x minus tan. The first thing in parentheses is 1.
So which one equals
Or the
1?
second one, I mean. Secant
So
squared
secant
x
squared minus tan squared equals 1. That was an identity that we had. This gives us a 1. So now we have secant squared x plus tangent squared x times 1. So now we're just left with this secant squared x plus tangent squared x. So always keep in mind where we're going with this. So we want to prove that that equals this 1 plus 2 tangent squared x. Always keep in mind where we're going. So if we're trying to get to 1 plus 2 tangent squared x, we already have 1 tangent squared x. So we might want to leave that alone. We have to get another tangent squared x and we have to get a 1. So can we do something with this secant squared x? So what does secant squared x equal? So it equals, we set this, we have an identity that tells us that this secant squared x equals 1 plus tangent squared x. We can rewrite that. That was one of our identities. And then we still have this tangent squared x. So now we can combine those tangents and we have 1 plus 2 tan squared x, which is what we were trying to prove, right? We were trying to get to that.
Is that it?
So you need to know those identities. I know, as frustrating as it is, those identities will help you.
Can we get like a little note card on?
I don't know yet.
We should have a quiz with a little note card, and then we can have a test
We
after.
should have a quiz that just has.
We should just not have a
We
test.
should just
not
We
have
should-
a test at all.
I like identity
We should just-
tests. I want to see what my personality is.
All right.
There's something on my camera.
So now we're going to look at example 5. We have
Oh, Georgine's pretty base.
secant squared x
What a babe.
plus cosecant squared x equals secant squared x times cosecant squared x. So this one, we're going to take that addition and we're going to make it into a multiplication. We want to prove that it's the same thing. So which side do we want to work with?
I think we should do the add one.
You think it's easier to work with the addition?
I don't really know, so listen.
I say the right side.
Why do you say the right side?
I don't know. Something just tells me that
It's like
we're going.
Oh.
I don't know why.
Wait.
I feel like the right side is the right side.
I say
You
right.
can work with either side. It's just which side is it easier
I'm thinking.
to make it look like? Is it easier to make a
I say
multiplication look like an addition?
Oh. I feel like it's left. I say.
I don't,
Because with the multiplication, you'd have to figure out how to break it up and figure out what you're adding.
You're the teacher.
Yeah.
Well, no, I'm asking
But I don't know.
I say
because these are the things.
I override. I
These-
think so.
These are the things you're going to have to ask yourself when you're solving these problems. Is which side do I want to start with? If you start with one side and you can't get anywhere, you get stuck, you might have to go back and start with the other side. So, you know, these are the things that you're going to have to look at. So with this one,
Left.
you guys want to start with the left-hand side. Okay. What can we do with that left-hand side?
Change cosecant to cotangent.
Kara.
So you want to do what?
Change cosecant to cotangent squared. Plus 1. Because then you can change secant with the quotient or cotangent. It's just, she's so quiet.
I think it'd be easier to do the right side.
I say right side.
Yeah, I think
Oh yeah.
at first I thought left, now I'm thinking right. I don't know.
So, okay.
This is the top side.
So work through this with me. We want to get the same thing back, but instead of adding, we want to be multiplying it. So do we have a way to combine our addition together without,
Actually adding them, because you can't.
well yeah, because these two, you can't actually add them.
But there's just an addition sign there. Like,
So,
it's frustrating. It's just-
well, if we actually had angles, you could add them, but.
But we don't use
We don't have
numbers.
numbers.
We don't
Yeah.
use.
Yeah.
So this kind of goes back to so you kind of want to, these problems that we've been working on, we've kind of all been working different things. The first ones, we rewrote them in terms of sine and cosine. The next ones, we use some of our identities. So you want to be able to combine all of that together. So that's kind of what you have to do in this problem. So this is going to kind of go back to what we were doing in those first few problems. We might want to think about rewriting this in terms of sine and cosine for now. Because we do eventually want to get back to secant and cosecant.
Can I do the
But-
same? Oh, okay, I got something.
Okay, so what would you like to do next?
Can I do something to the left side similar to what we just did, where it's, no, it can't be too perfect, we're just kidding, so it's a positive. Never mind, I lied.
Okay,
Thought we could do something similar, thought we could do
That's
something
okay.
factor, I lied.
so, okay,
Love me.
so
That's all that matters.
I'm kind of leaning towards our addition side. Because I have two separate things, but I know if I work through it, I can probably combine them eventually.
Maybe.
The multiplication one, I can't really figure out how I would break that up to make it an addition. I don't know exactly how I would do that. So that's kind of what I'm thinking. So what can I do to this left-hand side?
Can we
So we can rename them. So you can rewrite them using the identities, or we can rewrite them in terms of sine and cosine. Sines and cosines are usually always easier to work with. So secant squared is what? 1 over cosine squared. And then our cosecant is 1 over sine squared, right? Okay. So now, is there a way that I can combine these two fractions?
Oh, you.
Common denominator.
So I have to get a common denominator. So over here, what do I have to multiply to get a common denominator?
Sine
So I have to multiply by sine squared x.
under cosine? Oh my god.
And then what do I have to do on this side? I have to multiply by what?
Cosine squared.
By cosine squared x.
I want my degree in math now.
So when I multiply through, what do I end up with here? I have a sine squared x over my new denominator. And then I'm adding that to this new one, which is a cosine squared x over that sine squared x. Cosine squared x. So now, can I combine those two fractions now that I have a common denominator? So I have sine squared x plus cosine squared x all over that sine squared x cosine squared x. Okay, so now, if I look at this new combined fraction, look at each term. Do I know anything about those terms?
Top equals 1.
The top equals 1. That was our very first Pythagorean identity. Cosine squared x plus sine squared x equals 1. Just because it's reversed here, they're still the same thing. So we have 1 over that sine squared x cosine squared x. Now, we combine this. This is a multiplication on the bottom. Is there any way that we can break that apart again? Or do we have
You
to?
don't have to, you just flip it, because that's the inverses of the second.
So what are these? So what do these become?
Dare to be different.
Secant squared x.
Yeah.
So 1 over the sine squared
Cosecant.
is our cosecant squared. And the 1 over the cosine
Secant squared.
is our secant squared x.
And then you're good to go. That's all.
And these are reversed, but you can reverse them, so you can write it as secant squared x cosecant squared x. And that's what we were trying to prove. So when you're not sure what to do, try writing it in sines and cosines. All right, examples 6 and 7 are probably our hardest examples that we're gonna have. This, I know, this one was hard.
They get worse.
These make you have to think.
Don't underestimate.
And as much as I know you all hate thinking,
True.
one number.
Shut up, Jasmine.
These make you have to think. True.
Get your underclassmen sophomore looking self out of here.
All right. So number 6, we have 1 plus
You wanna fight?
cosine x over sine x.
Oh,
You guys need to focus. We've got 2 more examples.
Zornstein.
And we're adding this to sine x over 1 plus cosine x. And that equals 2 cosecant x. So which side should we start with?
Oh,
Right, you do close.
Right.
1. It's 1. I don't know.
It just.
So I'm hearing a lot of people wanting to start with the left side. There's more stuff that we can do over on the left side.
No, it's 1.
You just cross. No.
So
JK.
what can I do on the left hand side? What should my first step be?
Well, yeah. Cross.
Common denominator. Just like what we just did. Get a common denominator. So this side, we're going to multiply it by that 1 plus cosine x. And over on this side, we're going to multiply by sine x. And we're multiplying the top and the bottom, even though I only wrote it on the top. I didn't leave myself very much space. So this side, or well, this term is going to become 1 plus cosine x times 1 plus cosine x. That's over our new denominator, which is sine x times 1 plus cosine x. And then our second term we're adding is going to become, this is going to become sine squared x, because sine times sine. And then that's over the sine x times 1 plus cosine x.
Ow. Just foil.
So now you want to FOIL. Okay, so we're going to FOIL this. So what do you get when you FOIL this?
Cosine squared x.
So you take
1 plus 2
Well, I
cosine
just kind of
1 plus 2 cosine
x plus cosine squared x.
plus cosine squared x. And then, since we have common denominators, I'm just going to add our sine squared x on, so that we're all in one fraction now.
What are you trying to get this to equal now? Oh, 2 cosecant, I forgot because it's so far away.
Okay. So now,
You have this monstrosity of words.
so now look at each term.
Supercalifragilistic.
Is there something that we can do?
You can.
You can, the,
We can
oh, the
assign.
n equals one.
What part of the end equals 1?
The cos squared plus sine.
So this section equals 1.
So essentially you just okay.
So now we have
1 plus 2 cosine.
1 plus 2 cosine x plus 1 all over sine x
Oh.
1 plus cosine
I
x.
think you wait.
So add the ones.
Would you-
So now I can combine my ones, so I'm going to end up with 2 plus 2 cosine x all over sine x times 1 plus cosine x.
Can you take out?
So now what do you want to do?
Take out a 2.
Factor out of 2. So I have 1 plus cosine x all over sine x 1 plus cosine x.
Can you cancel those out?
So now I can cancel these out. I have 1 on the top, 1 on the bottom. So I'm left with 2 over sine x. So what does that mean?
Just go up and then these.
It's double
Just
cosecant.
flip it.
So this equals 2 cosecant x.
Toe?
Did I say toe? My bad. 2.
Thinking cosecant.
Sorry.
There's one more.
I don't have room for it.
I don't either.
Alright. So I know these are difficult, but you have to, basically they're all different, so you have to just practice doing them to figure them out.
What are you?
Alright, and we've got example 7. Alright, so example 7. We've got 1 over cosecant x minus sine x, and that equals secant x tan x. Okay,
So we got.
so which side do we want to work with? Okay, so we can work with the left. So we can work with the left-hand side. What? All right, so what can we do to the left-hand side?
You can.
Break the cosecant. So 1 over sine x.
Cosine.
1 plus.
Actually, Jim.
What are we going to do to the left-hand side?
Break up the cosecant.
Huh?
Could we break up the cosecant to 1 over the, what is that, sine?
So you want to rewrite the cosecant. So we have 1 over,
Yes.
what's cosecant?
1 over sine.
1 over sine x. And then we still have minus that sine x. Now what?
Because it's over multiply. Or is that minus sine x? No.
Well, the minus sine x is kind of in the way. So can we do something before we flip and multiply? Can we combine these somehow to get them to equal one fraction?
cancel them out? Can you? No? Was that not just over one? Can't you cancel them out?
X over sin X.
So this is like this is over like an imaginary 1. So how do I combine fractions?
So, yeah.
I have to get a common denominator. So I have to multiply this one by sin x over sin x.
So you're left with what, a sin x
So I'm going to have 1
over sin.
minus sin x times sin x is sin x squared, or sin squared x. And that's all over sin x. So that's what that bottom becomes.
That cosine
This all
squared x.
becomes that.
The top equals.
So now if I rewrite this as the complex fraction that it is, I have 1 over 1 minus sin x squared over sin x. What do I have to do now? So now this is going back to what you said, Brett. So now you can flip it and multiply.
Wait,
So we're, what?
can't you make 1 minus sin x cosine squared x? Isn't it just easier to have cosine squared x?
If you want to, yeah. So before we flip and multiply, you want to go 1. And you said that 1 minus sin squared x equals cosine squared x. That was one of our identities. Okay.
So it becomes 1 times.
So now you want to flip and multiply? Right?
Yes.
We're only multiplying by 1, so we can just flip this. So we get sin x over cosine squared x. Now remember what we're trying to get. We're trying to get secant x and tan x. So we have a sine on the top and we have a cosine squared on the bottom.
What equals tangent x? But you have to get secant x.
Now does sin x over cosine squared x equal tangent x?
Oh, the square.
And
I
then
did
you
not see
have
that.
1 over
part.
cosine
Yeah.
Because we're squaring that. So what do you want to do, Jeff? No, you want to? No, seriously.
Well, the sine x over the cosine x would be tan x, and then you would be left with 1 over cosine x, which would be.
So you can break this up. This can be broken up as sin x over cosine x times 1 over cosine x. So this sin x over cosine x is your tangent. And then you're multiplying by your 1 over cosine x, which is your secant x. And then in this case it's reversed, but you can just flip it, and it equals that secant x times tangent x.
That's fine.
At the bottom of the page, there are some strategies. We actually just used them when we were doing these. So you're transforming one side into the other. Choose one side, not both. Use substitution. So that's when we substitute it in. We know that cosecant equals 1 over sine x. Substitute that in. Write things in terms of sine and cosine. Use all methods of factoring that you know. And then know those identities that we did yesterday.